Hey folks, so welcome to Algebra 2, welcome back, and we're going to look at today something in Chapter 4. We're actually going to skip the remainder of the stuff in Chapter 3 and a lot of the stuff in Chapter 4 and just go on to something called inverse functions. Now the reason we're doing this, a little bit of background, is your textbook, yay, as good as it is, was written in about 2007, so that means it's 13 years old and is not aligned to the current curriculum. And the reason we're using it is it's here in the building, and we have a digital version, and it still has a lot of good stuff in it, just some topics that we can skip. So anyway, about inverse functions. The whole idea of an inverse function is you flip x and y, and then solve for y. Easy peasy lemon squeezy. Let's take a look.
As we get into talking about inverse functions, it helps to know, hey, what a function inverse is. Some notation first. If we have a function f of x, we write the inverse as f with a little exponent of -1 of x. Looks like this. The same as if I had something that was a function of g of x, its inverse would be g little exponent of 1x. And I pronounce this as g inverse of x. Now, please note it doesn't mean we have a negative exponent here. We'll talk more about negative exponents later in the year. It's just a notation. That's it. And it's read aloud as this, f inverse of x. So f inverse of x. Now, to find the inverse algebraically, there's only two steps. You switch x and y, and then after that, you solve for x. And you solve for x using SADMAP inverse operations, the same way you've solved for anything. And we're going to go through a bunch of examples here with a bunch of different types of functions. First off, here we have linear functions. They are y equals mx plus b. Now you might say, but wait a second, it says switch x and y. I don't even see a y. Well, we can write this as y equals 2x plus 5. Next step is we're just going to switch the x and the y. So wherever there was an x, there's now a y. Wherever there was a y, there's now an x. That's all we mean by switching it. Now I need y by itself. So I'm going to subtract 5 from both sides. Then I'm going to divide both sides by 2. Notice I'm dividing the entire thing over here by 2. I'm not just dividing the x, I'm not just dividing the 5. So I get y equals x minus 5 over 2. Now there's a bunch of different ways you could write this. For instance, if I were to divide both the x and the -5 by 2, I'd get x over 2 minus 5 over 2 equals y. So that could also just be 1/2 x minus 2.5 equals y. And we could also put the y as f inverse of x. But it's the same process all around. Now, let's solve out the other one. First step, I'm going to switch my x and my y. Then I'm just going to write the rest of it. -3y minus 10. Add 10 to both sides. Divide by -3 on both sides. X plus 10 over -3 equals g inverse of x. And that's the inverse. Now, you might be wondering, okay, what does this inverse even do? Why do we call it an inverse function? The inverse function undoes the original function. For instance, if I were to pick some random number, let's say I were to pick 5, and I were to plug 5 into, I'm just going to get rid of this, my original function here. So let's find f of 5. Okay, so f of 5 is 2 times 5 plus 5. That's going to be 15. And suppose I were to plug 15 into the inverse function. So I have 15 minus 5 over 2. That's 10 over 5. That's 10 over 2. That's 5. I got back the original number I plugged in. Just like the inverse operations that you use to solve this, inverse functions undo each other. They take what one has done and they change it back to the original. So if one inverse function adds 5, the other subtracts 5. If one multiplies by 2, the other divides by 2. And they're always returning the original. So these two were linear functions. Let's take a look at some nonlinear functions. We can still find the inverse function here. We still have the same steps. They look a lot different, but we're going to see in a second, they're not so difficult. So I'm going to first switch them. So that's going to be my x, that's going to be my y. I'm going to fill in everything else around it. And this is why we studied radicals first, because I need to be able to undo that exponent of 3. So that means I need a cube root. So over here, the cube root and the cube cancel. So I'm left with the cube root of x equals y plus 8. Cool, now I just need to subtract the 8 from both sides. And I have my y. And again, you can write this as the inverse of the original, so h inverse of x. Notice a couple of really important things here. When we are moving the 8 over, it stays outside the radical. The radical ends after it goes past the x. And it's a silly little thing in delta math, but it's really easy to make a mistake. After you've entered the cube root of x, make sure you're outside the radical for when you put the negative 8 there. Otherwise, you will get it incorrect, and it's a silly thing that's not really a math error, it's more a typing error. So that one had a cube root, or it involved a cube root. This second one has a fifth root to begin with. And we're just going to follow the same steps that we did, even though it looks a lot more confusing, and we're going to get it done. So we got x, we have y, I've just flipped the 2, so that just equals to the fifth root. Awesome, so I did my first step. Well, now I need to use SADMAP. I need to undo a fifth root, so that means I'm going to raise it to the fifth power. And what I do to one side, I have to do to the other. The fifth root and the fifth power cancel, so that means I have x to the fifth is equal to y plus 3. Cool, already that looks a lot easier. Now I just need to subtract 3 from both sides, and y is by itself. And I can rewrite this as f inverse of x. And we're done. We solved it out. So even though these were not linear functions, I mean, this one over here is a cubic function, this one is a fifth root function, their graphs look entirely different than linear functions. We solved it using the same thing. So we got a bunch over here. They look kind of confusing. We'll see that one in a second. So we got a bunch over here. They look really confusing. If you want to pause the video and try it on your own, see if you get it right, that's not a bad idea. If you're still a bit confused and want to keep going, let's keep going. So, first step, I'm going to flip my x and my y. Cool. My second step, I need to solve. Oh, I forgot that. And we're going to work our way from the outside in. First, I'm going to divide by 10 on both sides. Then I'm going to add 10 to both sides. And then I have to raise this to the fourth power. Notice I'm doing it to the whole side over here. I'm not just doing it to one term or another. And those fourth powers and the roots are going to cancel out. So I'm going to be left with x over 10 plus 10 to the fourth power equals y. And that also equals f inverse of x. Now, you totally could expand this out if you wanted to, but you don't have to, and Delta Math does not require you to do so. So don't worry about that. Let's make a bit of room. Next one again, if you wanted to try on your own first, you can definitely pause the video as I seemingly struggle on how to group an image. If you don't want to, hey, let's begin. First things first, let's flip them. I got to get rid of that square root, so I'm going to square both sides. The square root and the square are going to cancel. I'll do that in a different color. So that means I'm going to be left with x squared is equal to 5y minus 1. You might want to distribute that 5 first. That's not wrong. But another way we can undo it is just divide both sides by 5. Cancels out. And we're left with x squared over 5 is equal to y minus 1. And then I just add 1 to both sides. And I can also write that f inverse of x. And we did it. Looks weird, but we can totally do it. And if you wanted to combine this into one fraction, you could. I just need my denominators to be the same, and that would be my answer. Let's check out one last one. It's kind of a challenge, but I want to give it a shot. I highly, highly, highly encourage you. First, try this on your own. Write it in, pause the video if you're watching individually, or ask me, Live Gallagher, to do so. Hey, let's begin though. Alright, we're always going to start our way from the outside, work our way in. The root and the exponent cancel. They are inverses of one another. Then I'm going to multiply both sides by 5. They're going to cancel here. So I have 5x to the third is equal to y to the fifth. And then I just need to take my fifth root. And my fifth root and exponent of 5 cancel out. So I'm left with the fifth root of 5x to the third equals y, and I can use my other notation here as well. And we got it.
It's always a really nice thing to do. And while you could do this and see if they undo each other, there's also a way you can do so graphically using Desmos. So let's take a look. I'm going to plot my original function, the 2x plus 5. And I'm just going to set it to y equals. And I'm going to do my inverse function as well. And I'm going to use this one for the heck of it. So x minus 5 over 2. Just make sure that it is set up the right way. X minus 5 is in the numerator, and 2 is in the denominator. Now, you're going to see a particular relationship here. These are being reflected over the line y equals x. They're mirror images of each other over that line. If they're going to intersect, they're going to do it on that line. And we can check that with all of our inverses. Let's pick one that's a bit more interesting. Yeah, let's do this one. So x plus 8 to the third. And let's do the inverse, cube root of x minus 8. So you might be wondering how to put cube root. Go to Functions, Miscellaneous here, and you can click this one and then enter cube root. So it's x plus 8. Excuse me, minus 8. And you can see again, they intersect on the line y equals x. They're mirror images over that line. We can check it a third time with, let's pick that, that weird looking one. So we had the cube root of x to the fifth over 5. So cube root x to the fifth over 5. And then we had, as our inverse, the fifth root of 5x to the third. So let's do Functions, Miscellaneous, this fifth root, 5x to the third. And this one, if we zoom in, we can see that it is intersecting the line y equals x 3 times. 1, 2, and 3. So it just helps us. And this is a nice little way of checking to make sure, hey, you're right, before you hit submit. Great! So You've seen how to solve all sorts of different functions just using our flip x and y and use SADMAP. You've seen how to check on delta math for all of those different functions, and you have a really good understanding of how to do it. You can even check algebraically. Just plug in any random number for the original function, get a y, and then plug that y into the inverse. You should get your original random number. Right now, head on over to Delta Math and complete those 3 problem sets. Then, you're going to go and complete that summary. Alright folks, if you have any questions, ask them in the Zoom call, or see me in office hours. Have a great day.